let's start. Thanks for joining. We swapped topics. The presenter couldn't make it. So I'm here to talk about how we build and test the automotive grade Linux. My name is Jan-Simon Moeller. I'm doing the release manager work for AGL and taking care of the infrastructure side. Should turn it on. What's AGL? So, in principle, it's a Linux distribution for automotive. We use the Yocto project and Open Embedded, and we create a platform which can be used for multiple device profiles. IVI right now, telematics in the queue. So a platform for Linux in automotive. Our goal is open source and code first. And we support multiple architectures, like for x86, the Mino board is a reference platform for ARM32, the Renesas Porter, and ARM64 Dragon board is a nice candidate here. And I've seen Matt Porter posted on G+, Raspberry Pi 3 with 64-bit, so yay, that might be also an interesting target here. So why we do what we do, what tools we use, how we combine them, and what we want to achieve with that, call it stack. So our contributors, our developers, are distributed around the globe. Yeah, we have participators from Japan, so Asia. We have in Europe contributors in the US. So basically, all the time zones are involved. We have a public code review, as many projects do. Well, what we find out now, in the code review process, I can stare at the code, right? But, and say, it looks perfectly good. I do that kind of every day and say, works. And it builds fine, but it breaks on board N. And we need to find that early. And as you have seen during the conference, that actually must be a quite common problem. There were a lot of good talks during ELCE. There are multiple ways to skin the cat here, which is good because we can have different use cases and special needs here. So in the next slides, I will describe what we have set up, which kind of we think does the trick for our requirements or for what we want to achieve. If you have ideas or say, wait a minute, but that could be better like that, please, patch is welcome. So what tools do we use? Pretty much a standard set. Garrett, yes. We picked Garrett. Sorry, Greg. For CI builds, we use Jenkins. There are other systems there. For example, GoCD. Pick your weapon. For the tests on the hardware, actually, right now we use two, and I will tell you for which part of the game we use which. One is AGL JTA, which is basically Fuego, and Lava. And kind of the big, work in progress target is how do we kind of post-process all the data we basically gather then. So that's, in most cases, still a question mark or being worked on. So, Garrett, You can quickly take a look at git automotivelinux.org over here, number 2. And we have our main projects all within /agl. So hopefully the Wi-Fi works. Yep. So everything that's prefixed with AGL, that's our main projects. And let me switch back. We have a few repos where we are the upstream, that's in source, and we have, well, some scratch space where we want to try stuff out, poke at patches, that's in staging. For the main part, we use repo to pull down the repositories. Yeah. Now, basically, if we want to support all of these boards as we want to, so we have the reference platforms, which are right now the blue ones that you can see, ARM, x86 hardware, and an emulator target, which is good to have for quick boot tests or for tests which we can do on an emulator in the automation. And the green ones, which are our community platforms, you see that matrix starts to grow. Yeah? And if we want to see that it works on each board, then you basically have to test all these. That's nothing I can do on my desk because, well, number of boards times number of tests, times cups of coffee I drink in between, that would maybe work a day, but not on the second day because I didn't sleep all night. The CI builds happen in a Jenkins, and we use standard plugins here. So Garrett trigger plugin is used to poll our Git repos, and we use the OpenStack Cloud plugin, so we are in a cloud, for spinning up the minions, and all of the minions run off an identical base image, so we get reproducible build environments, always the same build environment. And to keep track of our CI jobs, we do that with Jenkins Job Builder. Now, again, there are multiple ways to skin a cat here. You could also use, for example, the Jenkins Job DSL. That's what Alexander described in his talk like a couple of hours ago. So there is no single way here to set this up. Now, Jenkins will give us the verified flag back to Garrett. So either verified +1, verified -1. And in our setup, no change goes in if we don't have the verified. Yeah? So basically, whatever we append to that chain for the CI build, which can be initially quite simple. Yeah? Yay, it builds. Up to it builds, boots, runs, passes all tests, updates cleanly, and shutdowns properly. That's an interesting test which quite often fails, as I've seen on a couple of boards. So pick your criteria here. At the moment, we are at the stage where it basically builds, boots, and to some extent passes tests. Yeah, so we are basically in the middle of that chain. Well, tests on hardware. Well, are they hard? You need the hardware. Yeah. For our community boards, that's relatively easy. Yeah, you can get a Raspberry for a couple of bucks, or Beagle boards. Now for the hardware in automotive, it might be a little harder. Usually you need it on your desk and in your lab, right? You need to have it close to you and be able to juggle the SD cards. That's quite time consuming. You need to deploy the firmware. You need to reboot the board and run the tests, collect the results, well, interpret the results, right? And then rinse, repeat for either the next board, for the next change. That is quite tedious and time consuming. So how can we automate that? Here you see an example that's set up with 6 Beagle bones, actually. And they can all be powered. They get their file system over network. So that's how we can automate that in the end. And as we have seen today and yesterday, I just picked a couple of pictures from slides that from talks of this conference. There's a pattern. Yeah, we see more and more of those automated labs here, and which is good because that drives the process, that helps us to ensure the quality of our code. If you are interested in such a lab setup, I'm in the process of documenting the setup that I use, and we have also documentation for JTA and Fuego. Just watch our wiki page that's here in the end. Speaking about links, the slides are not online yet. Yeah, they were just finished 10 minutes ago because it was really on short notice. They will be on the website soon. Yeah. So what tests and frameworks do we use? We use AGL-JTA, which is in principle a modified Fuego. And we modified it to run tests on one of our reference boards, the Porter. And we are building up the whole chain. There's an instant live jta.automotivelinux.org over here. This one. And that instance here is able to run a battery of tests, battery of benchmarks, functional tests. That's all built in, and we have our test sequence encoded in here. It produces quite a lot of results. It embeds a large number of tests, and we collect right now the results in a Git repo and push up for each revision, for each change set. We get a commit in the Git repo. What's good about that? We have the large set of tests that come with JTA. It's basically a Jenkins under the hood, so we have quite a few post-processing capabilities. We can use all the plugins that exist for Jenkins. So that gives us quite some power to post-process the results or do things based on the tests. A little hard is the installation. Well, I have a note here. It comes as basically a container, a Docker file, so you basically set up a container. you still have to inject the board information, the tool chain and such. Yeah, so it's not completely turnkey yet. We still had to modify things which means we have to we have to modify the Jenkins job XML files because the jobs are basically encoded right in Jenkins XML config files. Yeah, so I'm not really good at encoding stuff in XML. That's not how my brain works. So that might be just me and my blinders here.
FYI, just this week I finished a command line tool to allow you to inject stuff into the XML. So.
Looking forward to it. Looking forward to it. So that's where we can improve, right? One assumption is that the board is close to the Jenkins. Yeah. Basically, Jenkins wants SSH access to the board. And Jenkins needs to be able to power the board on and off. Yeah? So that means basically I have, well, right now there are two sides of the story. In company, well, fine. Yeah? You just put your boards close to your small machine that runs the Jenkins. Now with the project hat on, for the project we would host that somewhere. Yeah, how do we get the boards there? Yeah, problem. Yeah, logistics and problem-wise. So that's a little bit problematic for kind of the project side. Yeah, to use it in-house, that's perfectly fine. You set it up. Whatever trigger is used. So basically JTI would be triggered, either it would poll Garrett again, or it could be triggered by your CI build. Yeah. And that's what we do right now. We let our CI build trigger a test run. Also, the boards are basically set up as Jenkins slaves. So at the moment, I would only be able to use one Porter board. Well, or I would have to set up a new slave called Porter 1. Yeah, yes, that's possible. Yeah, but then I have to clone the configuration files again. So that's not there out of the box. There is no notion of a board type versus a single board of that type. Now we also use Lava. You might ask, what's now the difference? Well, Lava is now very good at managing your board farm. Yeah? So it basically knows a class of devices, and you can add multiple boards to this type, device type. So we can manage multiple boards, which helps us then also to run the tests in parallel, yeah, once we get multiple builds at the same time. It basically grabs a board from the pool, will power it up, boot it, test it. It can deal with the bootloader and so on. It can also execute tests, yeah, but the tests do not come as part of Lava. There's a test repo. Basically, you have a kind of a test shell in here. Whatever you run there, well, let's say different story. There is a Git repo which we can reuse. We can also run tests there. As I said, we can do multiple boards per board type. A remote lab is work in progress with the rewrite, so we can have kind of satellite dispatchers. So we have one hosted instance, the master, and we can have dispatchers where the boards are connected.
That now, the rewrite's now in a state where that works and the rewrite's usable.
Yeah.
So in new installs, that should be a lot easier than with V1.
Yeah, yeah. Yes, that's true. I just didn't find the documentation for the remote sites. The installation procedures.
Look at the slides from the presentation on kernel CI earlier this week.
Okay. Then reference these, please. So remote lab, that's what's especially interesting, because in the end, basically each developer has his 1 or 2 boards, and it would be nice if we can pool them to run tests on them. What even works is that you can stick it onto a Raspberry Pi face on top, so you have your relays for the powering, serial connectors on, maybe a network switch, and that will be already enough to run 2 boards. The setup, the initial setup, if you follow the instructions, is pretty straightforward. You have to have a Debian, and then you can just pull it down from the packages. The configuration files, the templates for the boards, probably start from one of the existing ones and modify it until it matches your boards. And I didn't find the doc for the satellite, but yeah, true. I pulled down the slides, but I didn't have time to look at them. So kernel CI, I will look at it. Yeah, so that's what we have active right now. That's Porter automotivelinux.org over here. You can go to it. Basically, that is the setup as described, Raspberry plus relay connected to one of the boards. So the docs are here. I keep track of an example installation as I redo it now with V2. So thanks for the hint. And I will update the document and the first link as I go through it. Then probably Saturday. And for Fuego, we have, for the AGL JTA and Fuego, we have a document in the docs folder. So there's a complete PDF how to install the container and then configure it. And if you have questions about setting that one up, just send it to the mailing list. We will jump in. For the whole thing, we have also a wiki page. So basically, a simple setup is basically less than 100 euros or bucks, depending if you count the device under test, in or not, plus minus. So that's the minimal setup. Actually, well, you can go bigger. So post-processing. As I said, right now we collect the test reports as they fall out of the tools, as they fall out of AGL JTA. Can we then post-process them well better, create trends, graphs? Yeah, because the raw data might not be meaningful per se. Yeah, unless we look at them with a pair of eyes and say, yeah, that's interesting. So how do we find out of this data set the hotspots, or can we find trends? So that's an interesting topic to work on. And also, what data do we want to track? Yeah. One example, kernel CI, you guys do great work. You track a lot of boot reports, right? For us, in our case, we might want to track, well, can the board send can messages? So on top of that. So what's our key indicators that you want to track? In the end, we want to give our developers a fast feedback. So in our Garrett, we added, beside the code review and the verified that comes from Jenkins, we added a couple of fields which will then get their tick as the process passes. Well, image build, as simplest case, we have, for example, a simple boot test, some small, short test runs attached, and we have the full test pass. That is, in our case, AGL, JTA, or Fuego, basically. And that is, the goal is that the developers need to see what's going on. Yeah? Does it pass on all devices? Because, well, in reality, you test one build, for example, QEMU, you test it for the device that you have in front of your nose. And yeah, it works, but more often we have seen that, well, for sure it will fail on one of the other targets, yeah, especially if you manipulate recipes around graphics, or if you manipulate recipes around, well, system D or whatever else, yeah, if we have to do tweaks there. So, how we combine them? At the moment, we have this setup over here. As I said, Garrett, Jenkins for the builds, JTA for running the tests, and at the moment, we get the board through Lava. Yeah, so Jenkins will basically push a job to Lava, request the board, and access it then. It runs the battery of tests, and we get the messages back in Garrett. Yeah, plan is to have those remote labs, which we should be able to do now, and also we have in mind to look into adding SPDX to the build. So, but that's mainly a build issue that doesn't have to do that much with the testing. Now, long term, we might just brainstorm and say, let's see if we look at how the SDKs develop. Yeah, if you look at the Yocto project with the extensible SDK, with the crops system, basically tool chain in a container, remote API to the tool chain. If you look at Eclipse G, kind of your IDE in the browser, well, you end up with kind of an environment where the developer sits on the web browser, doesn't have the compiler on his machine at all, and writes the code, and then, yeah, code, save, build. So the idea is that we can build the application, whatever, for example, in such a web IDE, build, click another button, and we, for example, get a job in Lava that will run the binary and test it on the board. Another idea is, what about the UI? UI testing is another interesting topic, but probably a big one on its own. There are systems out there. One of them is OpenQA. In principle, they run virtual machines. they take snapshots of the VNC, and you predefine, targets that need to be reached. Yeah. That's basically how it works. You can imagine if we work with sort of snapshots, that's a lot of work to create those snapshots. Well, maybe, let's see. What we want to achieve, in the end, stable and tested platform where we can build upon on a wide range of devices. We want to give fast feedback to our developers. We work remotely, yeah, and we are at conferences like ELCE, and oh, wait a minute, does it work? Yes, no, that will help to speed this up. And if we look ahead how the SDKs develop, the testing should keep pace here. Otherwise, well, everything goes on over here and we have to stop and put it through all the tests again. All right. Questions? All right. Thanks for joining. And if you are interested in those topics, send an email to our mailing list, Automotive Discussions. And if you have ideas, please. Thank you.